This next question comes from one of the 1-minute design review videos, and you can see here on screen we have a footprint that we're examining in the video, and in this particular footprint we have vias directly in the pad. The question is, what do we do with the vias in that scenario? I didn't get the solution. Well, the big problem with this particular footprint is that the paste mask is open over the entire set of vias in that central pad on that integrated circuit. So if you just go back and pause and take a look at that design review, or if you check out the link in the description and go and watch that design review, you'll be able to see that there are some vias directly in that pad on that integrated circuit. Now, normally you need the vias on die-attached pads on integrated circuit because they're there for thermal handling. The challenge is that if you open up the paste mask across those vias and those vias aren't filled, then solder can wick onto the backside of the board. And that isn't always a problem. Sometimes there's nothing on the backside of the board, so a little solder wicking never hurt anybody. Sometimes you have components on the backside of the board, and so if solder wicks through some of those vias, maybe it creates some shorts between components. The best solution here is to just close that paste mask just a little bit. By closing that paste mask a little bit, you'll confine the paste application directly to the pad in regions where there are no vias. By doing that, you can minimize or even prevent solder paste wicking through those vias to the backside of the board. An even better solution is to just fill and cap those vias, although again, it's not going to be necessary to do that in every single design. Filling and capping also requires planarization. Planarization, fill and cap also add cost to the board, so that's one of the factors you'll have to weigh when you're preparing a board for production.